This is a health data set, precisely autism diagnosis delay data set, and we want to run a predictive analysis on the drivers of the delay in autism diagnosis. We want to use machine learning models, precisely the random forest regressor. That is what we want to use. Why are we using this? Because we want to generate a predictive outcome. That is why we are using this. And of course, we have two types of variables here. We have the categorical variable and we have the continuous variable in play. Yeah. So what do? You don't assume that your data is clean. That is why we are going to be applying the 80-20 principle, which implies, in a layman language, 80% of our time is going to be devoted to cleaning the data, addressing data quality issues, while the remaining 20 is going to be used for analysis and reporting. So the first thing you do is to first check if the data is balanced. What do I mean? If there is any missing data, if any row is missing, then the data becomes unbalanced. So we must test, we must check for missing data. What do? Let's first bring the data alive. .head. Let's bring it alive. This is going to be a part 1 and part 2 session because I wouldn't want the videos to be long. Okay, can you see the data is alive? So let us check for missing data. How do we check? It is simple. That is data.isna open and close .sum. I want it to generate values to show if it's missing or not. Do you see? The zeros indicate the absence of missing data. This implies that there are no missing data in our columns. Our data set contains no missing data. What is the next thing we do? I'm going to be explaining that in the next video.